This is lesson 7.5, factoring x squared plus bx plus c. So a polynomial of the form x squared plus bx plus c is said to be factored, that's our goal, factoring this trinomial, when it's written as a product of factors in this form, x plus p times x plus q. P and q will just be some numbers, so we're looking at figuring out what numbers have to go in for p and q to give us some trinomial where b and c are going to also be some numbers. As I put here, the hard part of factoring this x squared plus bx plus c is finding the values of p and q. What numbers have to go here to give me that trinomial that I'm starting with? So in the past in class, we started with the product of binomials. We FOILed them together, which just means distributing, multiplying them together, and we got out a trinomial. In this lesson, we're going to start with the trinomial and try to go backwards and get that product of binomials. So let's try an example. So it says factor, so I'm looking for a product of two binomials that will give me this trinomial. So when you multiply binomials together, we're using that acronym FOIL. First, outside, inside, and last, which is just a way to help you remember that when you multiply binomials together, you need to distribute onto both of the terms over here and then take the term that would be here and distribute onto both the terms over there. So we are going to be thinking in the back of our minds about FOIL, first, outside, inside, last, and what numbers or variables would have to go in those four positions that when I FOIL this together gives me this trinomial. So we're working our way backwards in this lesson compared to what we did in class over the last couple of weeks. All right, so the first thing I'm looking at is the first two positions. What times what would give me an x squared? Well, obviously x times x gives me x squared. So those first two positions in this section are not going to be challenging because you're always going to have a leading coefficient of 1 in this section, and it's always going to be a variable squared. So if this was like a q squared, well, you put a q and a q. If this is an x squared, so we put an x and an x because x times x is x squared. All right, moving on. We need to think about when I multiply the last two together, I need to get a 6 because this will be a number times a number, and a number times a number is not going to make a variable. It's a number times a number is going to give you a constant like 6. So what two numbers multiply to give you a 6? Well, we have some options. We could use 1 and 6. We could use 2 and 3. Now, you could possibly have two positives because a positive times a positive is a positive.
Or two negatives because a negative times a negative is also a positive.
Let's think of some possible cases here. If I were to try x minus 1 times x minus 6, and I'm just trying to double check, is this the factored form of this trinomial? In other words, if I distribute or FOIL these together, do I get that trinomial? Just to double check that this is the factored form of that trinomial. So x times x is x squared. That's the first two. Multiply the outside 2, negative 6 times x is negative 6x. The inside 2, negative 1 times x is negative x. And the last two, negative 1 times negative 6 is positive 6, like I was hoping to get on the end. But when we simplify this, when we combine the two middle terms together, we end up with x squared minus 7x plus 6. So not only is this 7 not the 5 that we need in the middle term, but it's a negative. So what's going to happen, no matter what you try here, if these are both negatives, when you multiply the outside, you're going to get a negative some value times x, and the inside, you're going to get a negative some value times x. And when you have a negative minus another value, you're going to end up with another negative. So that is not going to be good. We do not want to have two negatives here. Yes, we can get that positive 6, but we can't get that positive in the middle. So if you see a plus sign here and a plus sign here, we do not want to use two negatives. That will not get us that middle term, no matter how hard we try. All right, so let's try some positive possibilities. So let's try x plus 1 times the quantity x plus 6, because again, when I multiply the last two together, I better get out a positive 6. And 1 times 6 is 6, positive 6. All right, so let's double check this. X times x is x squared. X times 6 is 6x. X times 1 is 1x, or just x, and then 1 times 6 again is that 6 that we're looking for. So we've got the x squared again, we've got the 6 on the end, but do we add the two middle terms and get a 5x? Well, x squared plus 6x plus x is 7x. plus 6. So note that possible case did not work for us. We did not get that 5x that we wanted, so this one is no good. So we know that a 1 and a 6, I'll just go ahead and erase those. Those are not going to get us what we need for that trinomial to be factored. So let's try the one other possibility here, just to double check that it should be x plus 2 times x plus 3. So let me just write this over here. Let me get rid of all the extra marks on here that we don't need. So this one, all these guys. Okay, so is x plus 2 times the quantity x plus 3 that trinomial that we started with? If it is, then this is considered the factored form of that trinomial. So let's double check. X times x is x squared. X times positive 3 is a positive 3x. X times a positive 2 is positive 2x. And 2 times positive 3 is 6. Do those middle two terms add to give me that 5x? Well, x squared, a positive 3x plus 2x is 5x, and then we have that plus 6 on the end. So indeed, that is our answer. This x plus 2 times quantity x plus 3 is the factored form of x squared plus 5x plus 6. That's what we're trying to do today. We're trying to start with a trinomial, break it down into the product of two binomials that if you were to FOIL them back together, you would get that starting trinomial. So let's try one more example. So on this one, again, I've got a trinomial. So if it's factorable, it should factor into the product of two binomials. Again, we've got that x squared to start here. So I know I need an x and an x because x times x is x squared. When I multiply the last two values together, I should get out a 7. So that right there should hint you to what numbers must go in these two positions. And 7 is a prime number. The only two possible numbers you're going to multiply together to get out a 7 are 7 and 1. I suppose you could make the argument of -7 and -1, but again, we've got two plus signs in a trinomial. So just like on this last example, it does no good to have two negatives because you end up with a negative middle term. We need to have a positive middle term. So I know that I need two plus signs. And with this being a prime, what times what gives you a 7? You only have one possibility, a 1 and a 7. Now I know some students ask, well, what if you put a 7 here and a 1 there? I can cover that possibility real quick here just to show you you're going to get the same thing. So if I have a 7 here and then a 1 in the other position, if I want to double check that this is the factored form of that trinomial, just distribute or FOIL these out. I get x times x is x squared, x times 1 is 1x, or just put x. 7 times x is 7x, and 7 times 1 is 7. Combine your like terms in the middle. X plus 7x is 8x. We have that plus 7 on the end. So, yep, that gives me that trinomial. So I could say that this is the factored form of that trinomial. But just to show you that it does not matter if you have the 7 there and the 1 there, or the 7 here and the 1 there, I'm going to distribute these to get x squared. The outside 2 gives me a 7x, the inside 2 a 1x, or just x, and 1 times 7 is 7. So again, I get 7x plus x. Yeah, it's in a different order than these two, but 7x plus x or x plus 7x does not matter. It still gives you 8x. So we do get the same result either way. And that's really back to the commutative property of multiplication. It says it doesn't matter what order you multiply in. If I put x plus 1 times the quantity x plus 7 or x plus 7 times the quantity x plus 1, I should get the same result, and sure enough, I do. So either one of those are acceptable answers. So there we go. That is the factored form of that trinomial. This example here is a little bit tougher than the previous example for two reasons, really. There are now negatives, not just positives. And then also this 10 on the end here is not a prime number. So now I've got more than one possibility. On this last example, it was a positive 7. I knew it had to be a 1 and a 7 in these two spots here. So in this example, we've got a 10, a negative 10. So I have to think of all the possible numbers, that possible pairs that multiply to negative 10. So if I'm going to write this trinomial in factored form, it should be the product of two binomials. I've got that x squared again, so I know that the first two positions here need to be an x and an x, because again, x times x is x squared. And now when I go to multiply the last two together, I need to get a negative 10. So what times what gives you a negative 10? So let's think of some possibilities. We've got a negative 1 and a positive 10. We could have a positive 1 and a negative 10, a negative 2 and a positive 5, or a positive 2 and a negative 5. So we've got some possibilities to check here. Sometimes these are worse. Sometimes it's not a 10, sometimes it's a 240. I mean, there could be a lot of possibilities that you need to check. But as you do these more and more, you start to see some patterns, and I'm going to talk about some of those patterns in a future lesson that will help you figure out which numbers would have to go here just a little bit faster. So let's try the first possibility, -1, +10. So if I were to FOIL these together, the first two, the outside two, the inside two, and the last two, if I FOIL these together, do I get that trinomial? So x times x is x squared, x times 10 is 10x, -1 times x is -x, and then again on all of these, when I multiply the last two together, I know I'll get that -10. So I can write that down. So I have x times x plus 10x minus x minus 10, and that's just from if I were to FOIL these back together. Well, do these middle two combine to give you that -3x? You can see 10x minus x is 9x, so this one is no good. So let's try the next one. So I'll cross out the first possibility. That did not work for us. So when you're working on your assignment, once you start to get used to these, you don't have to actually write these possibilities down. You can do them in your head. But until you get used to them, I recommend you do actually write everything down. It will help you to start to see those patterns that I was talking about earlier. So let's keep going. So we have the first two, x times x will always be an x squared. The outside two, well, now I'm looking at the second possibility here. So x times -10 is -10x. The inside two, a +1 times x is a +x. And the last two, -10. Do those combine into -3x? -10x plus x is -9x. I need a -3x, so that's no good. So let's get rid of that second possibility. All right, try the next one. X times x, x squared. X times 5, I'm onto the third possibility now. X times 5 is a +5x. The inside two, -2 times x is -2x. And the last two, -2 times 5 is -10. Do those combine to give you a -3x? Well, you have an x squared. A +5x minus 2x is a +3x. So it's close, but our sign here is a negative, and our sign down here is a positive, so that is no good. So it better be that last possibility, otherwise we're going to run into some issues, and we're going to talk about some polynomials that are not factorable down the road, but for this first assignment, all of the polynomials should be factorable. So let's see, it better be the last two here. So let's double check it. X times x is x squared. The outside two getting multiplied together is x times -5 or -5x. The inside two, +2 times x is +2x. And the last two, 2 times -5 is -10. So when you combine those like terms in the middle, -5x plus 2x, that is -3x. And that is exactly what we were hoping to get, the same thing as the original trinomial. So my answer, the factored form of this trinomial, is the quantity x plus 2 times the quantity x minus 5. And that is the factored form of that trinomial. The next example, again, we've got two negatives just like the previous one. This one is actually not too bad because, again, we've got a prime number out on the end here. So I just wanted to cover an example where we had a prime and two negatives. So taking a look at this one, I'm looking for two numbers that multiply to give me that -7. So again, I've got an x squared. I know the first two positions must be an x and an x because x times x is x squared. The last two need to multiply together to give me -7. So let's think of some possibilities. A -1 and a +7, or a +1 and a -7. Those are the only two possibilities that multiply to -7. I didn't mention this before, but these numbers do have to be integers. They have to be whole numbers in order to be factored. So we're not looking for decimals here. You need to tell me whole numbers, integers that could go in each of these positions. All right, so let's double check each one of these possibilities. So notice this is different. X minus 1, X plus 7, X plus 1, X minus 7. Those are different possibilities. You do have to consider both possibilities. So X times X does give you X squared. X times +7 is a +7x. -1 times x is -x, and -1 times 7 is -7. But those middle two combined on this one to give you a +6x, so that one is no good. We're looking for a -6x, so it must be the second possibility. Just double check that real quick. X times x is x squared. X times -7 is -7x. +1 times x is a +x, and +1 times -7 is a -7. Combining these like terms together, you get a negative 6x. So this one does equal that trinomial that you started with. So the factored form for that trinomial is x plus 1 times the quantity x minus 7. So it's not too bad if you have a prime number out here. Even if they're both negative, you just have to consider multiple possibilities. There's only two possibilities if that's a prime, though, so it's not too bad. Again, if you're dealing with all positives, like in example 2, and that's a prime out there, you only have one possibility. It has to be a 1 and a 7 on this one, whereas here with the negatives, you've got two possibilities. All right, the last example in this section is example 5. We're going to factor this trinomial. Again, we're trying to find the product of two binomials. I have an x squared for my first term, so I must have an x and an x in the first positions. And then the two numbers on the outside here, or I'm sorry, in the last two positions, need to multiply to give you a 9. So we've got options. We've got a 1 and a 9, 3 and a 3. And now I've got to look at my signs. Well, I need them to multiply to a positive 9, but here I've got a negative 6. So let's think about that. When I multiply the first two x's, I will always get an x squared. When I multiply the outside 2 and combine it with the inside 2 getting multiplied together, I need to get a negative 6x. So how am I going to get a negative 6x when I'm adding those two terms together? And then I'm also going to need a positive 9 when I multiply those last two together. Well, how is that going to happen? Both of these are going to have to be negatives. So either x minus 1 and x minus 9, or x minus 3 and x minus 3. So let's take a look. So x times x is x squared. X times 9 is a negative, x times negative 9 is a negative 9x. A negative 1 times x is a negative x. And negative 1 times negative 9 is a positive 9. So let's see what we get when we combine the like terms in the middle. We get a negative 10x. And the plus 9 in the end, so we did not get that negative 6x that we wanted, so that one's no good. So I can ditch that first possibility. So let's double check the last one here, x minus 3 times x minus 3. I've got x times x is x squared. X times negative 3 is negative 3x. The inside 2, negative 3 times x is negative 3x. And the last two, negative 3 times negative 3. Sorry about that. Negative 3 times negative 3 is a positive 9. Combining the like two terms in the middle, get rid of that little mark there. Combining the like two terms in the middle here, I get x squared minus 6x plus 9, and that is the original trinomial. So the factored form of this one is x minus 3 times x minus 3, which you can combine as x minus 3 quantity squared, and that is my answer, x minus 3 quantity squared. So that is it for lesson 7.5, factoring trinomials. Now, just to recap, all of these trinomials in lesson 7.5 are going to have a leading coefficient of 1. So you will always have the same variable go in those first two positions. Your main goal is to think about the two last numbers that when you multiply together give you this third term, this constant term. And then now hopefully you started to realize that when we pick those two numbers, we're going to have to multiply the outside 2 and the inside 2 together, and then those will always get added or subtracted together. So you have to think about the two numbers that multiply to the constant, but add to give you this middle term. So hopefully that will help you a little bit. Look for the two numbers that multiply to this last constant, but add to give you the middle term. So try your best. If you have questions, feel free to contact me. My contact information is on that printout that I gave you in class or on Schoology, but please try your best. There are extra resources online. Just if you're going to search for additional resources, make sure you say factoring trinomials with a leading coefficient of 1. If you don't have a 1 here, things get a little bit more complicated, and we're going to get into that eventually. But for this first lesson, make sure you look up with a leading coefficient of 1. So your assignment is a worksheet called Factoring Polynomials. Please take a look on Schoology for that. And don't forget to turn it in on Schoology. Don't send me an email with your homework. Please keep it all on Schoology. So you take a picture of it or you scan it, and then you can upload it right into Schoology. And if you have any issues with that, please let me know. You can send me an email to let me know that you have issues. Or you can call or text the phone number that is on that printout from class. Otherwise, I also put my information on Schoology And I suppose I can just show you that real quick here, just so you know where to find it. I already got it open over here. So on Schoology, if you go into your algebra course, I believe online learning plan right here is going to have my information. I don't know if I also put it in the update. I've got my email in the update here. But yeah, ultimately it's going to be in the online learning plan document on Schoology. So if you look down at the bottom here, let it load. Look down at the very bottom. I've got my email address here. I also have my phone number right up here, 920-328-5212. You can reach me at any of those, and please keep it within the 11:30 to 3:30 p.m. time frame. If you don't, I can't guarantee that I'm going to get right back to you, but otherwise I'll do my best to get back to you as soon as possible. Hopefully I don't get too overwhelmed with questions, but let's just hope this all works smoothly. If not, we'll get through it. All right, have a good day.